Hello, ladies and gentlemen. Let's go ahead and get started now on Chapter 5. So this will be the audio video of Section 5.1. So what I want to do is kind of refresh our memories. Where are we? What have we been doing so far? So the first thing we've done is in Chapter 1, we talked just in general about the nature of probability and statistics. Chapter 2 was the frequency distribution. And then Chapter 3 was data description. Okay, now the reason I want to review this is because I have done this more than once, and I understand how confusing it can be. When we're in the data description chapter, we talk about the shape of the actual data, the measures of central tendency, for example. So we have the mean, the median, and the mode. We talked about the measures of variation. That's how spread out things are. We talked about measures of position. So that would be an example like, your kid comes home and says, hey, I was in the top 10%. So where is he? What position is he in all the data points, okay? So we talk about the shape of the data here in Chapter 3. Well, then we took a little bit of a side, we went off on a side journey, so to speak, and we talked about probability. That seems like it's a different concept, okay? But it really is not. Probability is the number of successes over the number of possibilities in the sample space. So it's just typically a fraction, okay? Well, now we're going to talk about a probability distribution. And the reason there's confusion is because in Chapter 5, as we're talking about a discrete probability distribution, we're going to see things that are very similar. Just a minute ago, I was showing you Chapter 3, and I hope you're following along in the book. In Chapter 3, we had the mean and variance, standard deviation, and so forth. Well, that was the shape of the data in Chapter 3. Now we're talking about a probability distribution. We're not talking about a frequency distribution. Now we're talking about a probability distribution, and we have words that sound exactly alike. So people get very confused. They're like, well, my gosh, I don't understand the difference between the mean of a frequency distribution and a mean of a probability distribution. So before I get into this, let me see if I can try to clarify that for you. Okay, so here's the way I look at this. I think this is a very good way of looking at it. When you're talking about Chapter 3, you're talking about a data description. These are data points. These are things that have actually already occurred. I have already measured everyone's height. I have already measured everybody's IQ, whatever it happens to be. That's their data. That's Chapter 3. It's something that you've already measured. Whereas in Chapter 5, what we're talking about is a probability distribution. That's something that has not yet happened. If it already happened, we wouldn't be in Chapter 5. We wouldn't be talking about probabilities. We would be in Chapter 3 if we've already taken the measurements. So as an example, using today's crisis, talking about the coronavirus, if you're talking about how many people actually have the disease right now, you're in data description. This is a frequency distribution. You would talk about, for example, measures of central tendency. You would talk about the sample mean of this frequency distribution and so forth, okay? On the other hand, if it hasn't happened yet, if we're talking about what's going to happen in the future, what is our best prediction, that is an example of inferential statistics. Remember there's descriptive statistics and inferential statistics. The descriptive would be what has already happened. Let me describe what has already happened. Inferential would be, an example of inferential would be probability distributions. This is what might happen in the future. I cannot guarantee it's going to happen, but this is the probability. This is the chances of it happening. I'm going to talk about a probability of something happening. So that's our probability distribution as opposed to our frequency distribution. So if it's already happened, that's Chapter 3. If it's something that's in the future, that's Chapter 5. Okay, that's how I think about it. So what I want you to do is make sure you read the book, okay? The book is very well written. So if you don't mind, I'll continue with using as an example this coronavirus situation that we're in. Okay, so if you're measuring people and you're trying to figure out what percentage of the population currently has the disease, that's chapter 3. Now we're going to talk about probability distributions, and we're going to be in chapter 5. So this is in the future. What do we think is going to happen? So here's an example of a problem. This is a real life problem. As you all should be aware, this coronavirus thing has really caused a bunch of problems in our society. One of the problems is, or one of the difficulties is, that we don't have enough testing. The public health people say we want to test everybody that we possibly can. Well, there's not enough test kits. There's not enough ways of doing these tests. So one of the proposals is what's called pooling. Okay, so what you do is you take you combine or pool the blood samples of a group of individuals into one batch, and then you test it. If it's negative, then you don't need to do any more testing, because all 20 people or all 50 people or however many people you put in that pool, none of them have the disease. Okay, so if it's positive, unfortunately, you don't know which of the people in the group made it a positive test, so then you have to go back and you have to test everybody that is in that batch or in that pool. So as an example, let's just take, instead of looking at their example, I'll let you read that yourself. The example that I would share with you is, let's suppose you had a dormitory of 500 kids, all right, and you're thinking, oh my gosh, how are we going to test all 500 of these kids? Well, you don't. What you do is you put them in pools or batches of maybe, say, 50 kids. So you draw the blood, you test 50 at a time, and you hope for the best. And the first 50 is negative, the second 50 is negative. Oh, here we go. The third 50, that pool has positive. So now you test all 50 of those kids. Well, instead of you may say, well, that seems like a lot of wasted effort, but it's not, because you didn't have to test everybody in the first group of 50. You didn't have to test everybody in the second group of 50. So it's a very good way of doing this sort of public health testing. All right, so we're going to see here in a little bit, at the end of the chapter, we're going to see the answer to this question. Here's a hypothetical example. Suppose the probability of having the disease is 0.05, okay? So it's 5%. You have a pooled sample of 15 people. What's the probability? You know ahead of time that the probability of having the disease is only 5%. You take 15 people. What is the probability that no further testing will be needed for this group? In other words, what's the probability that there are going to be 0 people that would come back positive? So what we're going to learn here very shortly is that you can answer these kinds of questions using the binomial distribution. So this is an example of current events where statistics is very important. I guarantee you, all those people at the public health department, they all took this class. Okay, so we're going to talk about this various distributions. We're in chapter 5. So chapter 5. Come up here. Chapter 5 is discrete probability distributions. And then later we're going to talk about continuous probability distributions. The discrete compared to the continuous, what that is referring to is that's referring to what kind of a random variable do you have. Do you have a discrete random variable, or do you have a continuous random variable? So we'll get to that here very shortly. This is still the introduction. We're talking about, in this introduction, what it kind of boils down to is a probability distribution is just a way of describing what the probability is for various outcomes. In fact, what's the probability for all of the outcomes? How do you organize that? What's the way of handling that? Okay, so this is, I'm going to go ahead and stop this video now. This is the video for chapter 5. I said it was going to be 5.1, but I'm actually in error. This is chapter 5, the introduction. Okay.